Hey guys, this is Vignesh and you're watching Math Mechanics. Welcome back. In the previous video, we discussed how to integrate trigonometric functions of power 1. But today, we will discuss how to integrate trigonometric functions of power greater than 2. Here are some simple examples. Integral of sine cube x dx, integral of cos power 4x dx, and integral of tan to the power of 5x dx. If you observe, I chose the integrands with odd powers and even powers because the technique of integrating odd powers of trigonometric functions and even powers of trigonometric function is going to be a little different. If you don't know what is an integrand, check out my previous video. It is going to be displayed right over here. Please check it out. Alright, let's get back into the video. Let's solve our first problem, which is integral of sine cube x dx. The way I would solve is first split this sine cube x as integral sine square x into sine x dx. I know that derivative of cos x is minus sine x, right? So I will use that and replace this sine x dx in terms of cos x, right? So let's just do that first. D by dx of cos x is minus sine x. So I can write minus d of cos x is equals to positive sine x dx. What I just did is basically bring this dx here and minus sign over here. So minus d of cos x is sin x dx, right? So I'm going to plug this for sin x dx. I'm going to plug minus d cos x for sin x dx, right? Integral of sine square x minus d of cos x minus integral sine square x d of cos x. So now my differential is d of cos x and the integrand is sine square x. So I need to convert my integrand in terms of differential. So that means I have to convert sine square x in terms of cosine. So convert it into cos. I will use the trigonometric identity cos square x plus sine square x is equals to 1, right? So I can write cos square x plus sine square x is equals to 1. So sine square x is 1 minus cos square x. Therefore, our integrand is 1 minus cos square x d of cos x and negative symbol over here. So just distribute this differential all over minus d of cos x plus integral cos square x d of cos x. Isn't this looking like our standard formulas? Minus integral dx plus integral x square dx, right? But we just have cos x. We know how to integrate dx and integral x square dx. In the same way, we can integrate d of cos x and cos square d of cos x. So what do you think is our final answer? It is going to be minus cos x plus cos cube x divided by 3 plus integration constant c. This is going to be our final answer. Because integral dx is x, integral x squared dx is x cubed by 3. So since we have d of cos x for our differential, we're going to write in terms of cos x minus cos x plus cos cube x divided by 3 plus integration constant. Now, if we want to verify our answer, we can do one thing. We can derive this final answer to get our integrand function sine cube x. So if I derive cos x, it is going to be minus cos sine x. So it is minus of minus sine x. And cos cube x derivative is 3 cos square x. And derivative of cos x is minus sine x because this is a chain rule divided by 3. And integration of constant is simply 0. So I'm not going to write that. So 3 and 3 would get cancelled. Negative times negative is sine x plus, and the sign in between is minus. So minus cos square x into sine x. I can take sine x common. Sine x common. Sine x off 1 minus cos square x. So sine x 2. 1 minus cos square x is sine square x, and this is sine cube x. This is our initial integrand. So we got our integrand when I derive the answer. So this says that our answer minus cos x plus cos cube x divided by 3 plus c is the correct answer. Let's summarize what we just did. So our problem is to integrate sine cube x with respect to x. So the first step I did is to split this odd power into one even power and sine x dx. Even power into sine x dx. So I know that I can write this sine x dx as d of cos x. So sine x dx will be minus d of cos x. And you can plug that for sine x dx. So I just did integral of sine square x times minus of d of cos x. So I brought the negative sign outside of the integral. So it is integral sine square x d of cos x. The next step, I converted this sine square x in terms of cos using the trigonometric identity. So I have written 1 minus cos square x for sine square x and distributed the differential d of cos x minus integral d of cos x plus cos square x d of cos x. And this is just looking like our integral dx and integral x squared dx. So we can apply our standard formulas, but we will just use cos x for x. So final answer would be minus cos x plus cos cube x by 3 plus c, right? Now let's move on to the second problem. Integral cos power 4x dx. The method to integrate an even power is slightly different than an odd power. You will see the difference. So the way that I would do is I can write cos square x in terms of cos 2x as cos 2x plus 1 divided by 2, right? So what will happen to cos power 4x? Cos power 4x is simply cos square x whole square. So cos power 4x is going to be cos 2x plus 1 by 2 whole square. So if I square the numerator, it is going to be cos square 2x plus 1 plus 2 times cos 2x divided by 2 square is 4. I still have this cos square 2x. I don't want any squares or fourth powers. I just want like this, power ones, like cos 2x. So what I'm going to do is apply this formula, same formula again, but write cos square 2x is equals to cos 4x plus 1 by 2. So let's just apply that here. So cos square 2x is cos 4x plus 1 over 2. And I will plug this over here. So cos power 4x is, so cos 4x plus 1 by 2 plus 1 plus 2 cos 2x and whole divided by 4. If I simplify this, it is going to be cos 4x plus 1 plus 2 plus 4 cos 2x divided by 2 into 4, 8. So I multiplied this 2 here and here and multiplied this 2 over here again. So cos 4x plus 1, cos 4x plus 1 plus 2 plus 4 cos 2x divided by 8. Now I have all the trigonometric functions are power 1. I have an invisible 1 over here. So cos 4x power is 1, cos 2x power is 1. Now I can integrate this function. And this particular thing can also be further simplified as 1 by 8 cos 4x, and I'm going to write the cos 2x term next. So 4 by 8, which is 1 by 2 cos 2x, and 1 plus 2 is 3, so 3 over 8. So cos power 4x can be written as 1 by 8 cos 4x plus 1 by 2 cos 2x plus 3 over 8. You see why I have converted this fourth power of cos x in terms of cos 4x and cos 2x? Because I can use this particular formula. Integral of cos kx dx is equals to 1 by k sine kx plus integration constant, right? So integral of cos kx dx is equals to 1 by k sine kx plus c. For cos power 4x, we can plug 1 by 8 cos 4x plus 1 by 2 cos 2x plus 3 by 8 and use this particular formula integral of cos kx dx. So let's just do that. Integral of cos to the power of 4x dx can be written as integral of 1 by 8 cos 4x plus 1 by 2 cos 2x plus 3 by 8. So everything has dx. So we will distribute this integral symbol for each and individual term. So I can write this as 1 by 8 integral cos 4x dx plus 1 by 2 integral cos 2x dx plus integral of 3 by 8 dx. So if I apply this formula here, it is going to be 1 by 8 sine 4x by 4 plus 1 by 2 sine 2x by 2 plus 3 by 8 x plus c. because 3 by 8 is just a constant. 3 by 8 integral dx is going to be x. So we can simplify this further a little. So sine 4x by 32 plus sine 2x by 4 plus 3x by 8 plus integration constant c. So this is our final answer for integral of cos power 4x dx. Let's summarize what we just did. In our question, we have integral cos power 4x dx. So what I did is I'm trying to do a relationship between cos square x and cos 2x. Cos square x can be written as cos 2x plus 1 over 2. So my integrand is cos to the power of 4x. So I need to square my left hand side. So cos square x whole square will give me cos to the power of 4x. So I need to square this one. Cos 2x plus 1 by 2 whole square. That will become cos square 2x plus 1 plus 2 cos 2x divided by 4. And I have cos square 2x again. So I don't want cos square terms. I just want power 1 terms. So I want to convert this cos square 2x into cos 4x. So cos square 2x can be written as cos square 2x is cos 4x plus 1 by 2, and plug this relation in the equation. So cos power 4x will be cos 4x plus 1 by 2 plus 1 plus 2 cos 2x whole divided by 4. So if we simplify further, we will get cos power 4x as 1 by 8 cos 4x plus 1 by 2 cos 2x plus 3 by 8, right? The reason why I did all of this is to use this particular formula. Integral of cos kx dx is 1 by k sine of kx plus integration constant c. So integral cos power 4x dx will be integral of all these three terms. So it will give me the final answer as sine 4x by 32 plus sine 2x by 4 plus 3x by 8 plus integration constant c. All right, let's jump to the third problem. Integral of tan to the power of 5x dx. The way to solve this particular problem is split this tan to the power of 5x into tan cube x into tan square x. And I will rewrite this tan square x in terms of secant square x. And you will know why I'm doing this in a bit. So integral of tan cube x, tan square x can be written as secant square x minus 1. So this is going to be integral tan cube x times secant square x dx minus integral tan cube x dx, right? But we know that the derivative of tan x is secant square x. So I can write secant square x dx as d of tan x. So integral tan cube x d of tan x minus integral tan cube x dx. So again, I will do the same thing. Split this tan cube x in terms of secant square x, tan x into tan square x, right? Tan x into tan square x dx, and do the same thing that I just did. If I simplify this integral tan cube x d of tan x, it is going to be tan to the power of 4x divided by 4. Tan power 4x divided by 4 minus, so tan square x can be written as integral tan x into secant square x minus 1 dx. right? So just distribute it. Tan power 4x by 4 minus integral tan x into secant square x dx, minus into minus plus. So it is going to be plus tan x dx, right? So secant square dx can be written as d of tan x. So write that tan to the power of 4x by 4 minus integral tan x into d of tan x. And integral tan x dx is simply natural log of modulus secant x, right? So this is very simple. It is simply looking like integral x dx, but we have tan x. So it is going to be tan power 4x by 4 minus tan square x by 2 plus natural log of modulus of secant x, and finally our integration constant c. This is going to be our final answer. Tan to the power of 4x by 4 minus tan square x by 2 plus natural log of modulus of secant x plus integration constant c. I like this problem. This is kind of simpler than the previous problems. So let's just review what we just did. So the integrand is integral tan to the power of 5x dx. So I split that tan power 5x as tan cube x into tan square x because I know that I can write this tan square x in terms of secant square x. So I, I have rewritten tan square x as secant square x minus 1 and distributed that. So integral tan cube x into secant square x dx minus tan cube x into 1. So integral tan cube x dx. This will give me integral tan cube x. So I can rewrite the secant square x dx as d of tan x. So that will become integral tan cube x d of tan x minus. So now I simply have integral tan cube x. So I will repeat the process. So split this tan cube x into tan x into tan square x and rewrite this tan square x as secant square x minus 1. So the first term is tan to the power of 4x divided by 4 minus integral tan x into secant square x dx. Minus into minus is positive integral tan x dx. So we have minus integral tan x d of tan x. So that is tan square x by 2 and integral tan x dx is natural log of modulus of secant x plus integration constant c. Let's stop it here and thank you so much for watching this video. If you think this video is helpful for you in any way, give it a like and share your thoughts, comment down below, and please subscribe to my channel Math Mechanics for more videos like this.